All right, problem number 16, a calculator problem. The height of an object in meters at time t seconds is given by that equation. Find the instantaneous velocity of the object when it hits the ground. So, graph this thing on your calculator. You're going to get a parabola that looks like that. And we want to know what is the instantaneous velocity of the object as it hits the ground, which means we need to find the derivative. The derivative of a position function is a velocity function. So we need to find the instantaneous velocity, whatever that x-intercept is. So graph it, calculate the x-intercept. So do second calc 0, which is option 2. Do a left bound to the left, do a right bound to the right of it. Calculate that value. It's going to say x equals something. Quit out of your graph. So if you hit clear twice without moving your cursor, you'll exit out of your graph without changing the x value. Now the variable x, if you hit the x button, is stored with that x value. And what we want to do is we want to store that as another variable. So hit x stow, gives you a little arrow, it's above the on button, and then hit alpha a, and it's going to store that x value to a. Because now we can go back into our graph and we can hit second calculate. Option 6 is dy dx, which you should know means derivative, and we want that at the x value of a. So hit alpha a, and it will calculate the derivative at that x value, which you should find to be 5.921. So that is the instantaneous velocity of the object as it hits the ground. We also want to find the instantaneous velocity of the object when it is 2 feet off the ground. So graph the line y equals 2. And in a similar manner, calculate the intersection point between the graph of the function and the horizontal line, y equals 2. It again gives you an x value. I want you to again quit out and store that x value to the variable a. You can actually just hit enter on the home screen. It'll do it automatically based off of that's what you did last time. Then go back to your graph and go back to second calculate and go back to option 6 and go back to hitting alpha a to take you to the x value of a, and go back to hitting enter and go back to figuring out that your answer is that the instantaneous velocity of the object when it is 2 feet off the ground is wait, what? Oh, oops. I just found the instantaneous velocity of the horizontal line, so that's not very good. So second calc dy dx, make sure you're on the correct graph, then hit alpha a, and then see that the derivative is negative 29.367. And I just realized that I gave you the x value over here. I gave you the time when it hits the ground, so I totally messed that up. So we need to again second calculate the 0 of this function because I messed mine up. Did you do it correctly? Because I clearly didn't. So we find the 0 is that. So I'm going to quit out, store that 5.921 as a again, and now second calculate dy dx on my parabola at the x value of a, to see that the derivative should have been negative 30.027. My bad. Units for all of these should be meters per second.